Alrighty, everyone. Good evening. This is meteorologist Timmy Albertson here at the guys for tonight's weather chat, which will also serve as a tropical update. We have Hurricane Norma out in the East Pacific. Just recently became a hurricane. She's continuing to intensify pretty nicely. We also have our latest tropical system out in the Atlantic Ocean. We'll take a look at that too here. So, with that in mind, folks, let's go ahead and take a look at Norma. Now, Norma, if you remember this time last night, was just a little tropical storm, 40-mile-an-hour winds, but it's in an environment that does not have a lot of wind shear. We've talked about this before. If you are a hurricane, you do not want a lot of wind shear because that kind of offsets everything. I know it's kind of interesting. We talk about tornadoes and hail. You want wind shear, but for hurricanes, you don't. Anyways, it's also over some very warm water temperatures. This part of the Pacific tends to be a little bit on the warm side. So those conditions have enabled Norma here to kind of quickly intensify over the past 24 hours. And it's likely that this kind of quick intensification is probably going to continue into the overnight tonight and maybe even going into the day tomorrow. So let's talk about the forecast track here of Norma. And basically, she is going to kind of drift her way up towards the north, right now moving about 8 miles an hour, and not the fastest moving tropical system, but at least it is moving a little bit there. And there's this little bit of a ridge off towards its east that it's kind of moving around. Now, as we go our way into the day tomorrow, it's very likely that by the time we do tomorrow's weather chat here, Norma will be noticeably stronger than what it is now. However, as we go towards the weekend, it's going to start running into some wind shear, and that could actually start to cause it to weaken a little bit. Then it could maybe get close to the extreme southern point there of the Baja Peninsula, and that might also kind of help it to weaken off a little bit. Now, it should be noted that with the National Hurricane Center right now, there's still a little bit of uncertainty with the forecast, especially once we go beyond about 3 days. There is quite a bit of variation with some of the models, but at least in the near term, what it's looking like is Norma's going to stay over the open waters, which again is another good thing. If you're a hurricane, you kind of need the water. And it's going to remain in an environment, at least through the next 24 hours or so, that's going to be very favorable for obviously this intensification. If you look at the infrared satellite imagery below me, again, she just got her eye within the past hour or so there, at least on the satellite imagery. You can kind of see a little bit of a ragged eye trying to form there. And some of the recent satellite imagery still shows that eye there. So again, developing really nicely here. Obviously, high waves will probably be a thing across parts of the western Mexican coast. As far as the direct impacts, though, as it gets closer to land, still a little uncertain, and part of the reason for that is still some uncertainty with the intensity, maybe beyond about 48 hours or so. So that is out in the Pacific Ocean. Pretty cool. Always like these East Pacific hurricanes. Sometimes they tend to like to sometimes kind of quickly develop. Uh, anyways, anyways, moving rapidly along. Let's go ahead and take a look, folks, at our latest friend out in the Atlantic. Welcome, Tropical Storm Tammy. Okay, it doesn't look quite as impressive as Norma there. Maybe I guess I should have started out with Tammy first and then gone over to Norma. But regardless, there it is, right below. You can see here, just kind of a little blob of some concentrated thunderstorms right now. And what is it likely going to be doing? Well, the thing about Tammy is, ironically, has been the issue with the past couple of tropical systems we've had is that there might be a little bit of wind shear in the way. So that's right now why we're not expecting that Tammy is probably going to intensify as quickly as what we're seeing Norma. Even though it's going to be moving over some very warm water temperatures, it may be dealing with some wind shear. That's going to kind of disrupt it a little bit. So right now, it's looking like Tammy is mainly going to be staying as a tropical storm, at least through this current forecast. Now, we'll see maybe if it's able to overcome some of that wind shear and maybe intensify a bit more. Maybe you might end up seeing it becoming a hurricane, but at least for right now, it doesn't look like it's going to be a very strong system in the near term. But again, things could change maybe later on as we go beyond, second half of the weekend and maybe going into next work week. Now, right now, it's looking like Tammy is mainly going to be staying out in the open waters. With that in mind, though, if you're familiar with the Lesser Antilles, there's a lot of islands out across that way. They're not big islands, but they're there nonetheless. And because of that, tropical storm watches are in effect for parts of the Lesser Antilles, especially the northern part there. So And again, that's going to be as maybe we go into the day Friday and into Saturday. It could be seeing some tropical storm force conditions, but again, right now it's not looking like it'll be a very strong tropical storm when it does pass by there. But again, still some uncertainties here with the system. And again, kind of one of the wild card is going to be how much that wind shear is going to play into a role. So I know we've talked about tropical storms and hurricanes. I explained this last night. We'll just go over very quickly again for those of you who might not be familiar. In the Atlantic, East Pacific, and Central Pacific, we use the Saffir-Simpson wind scale to rate tropical systems. All we have to do is estimate what the maximum winds are within that system, and that's how it gets its classification there. So we've talked about this before of tropical systems. Listen, folks, even with hurricanes, the whole thing is not 100-mile-an-hour winds. It's normally it's just a kind of a small area right around the eye wall when we're talking about hurricanes. So again, the whole thing, like Norma right now, 80-mile-an-hour winds. The whole thing does not have 80-mile-an-hour winds. It's just likely in a very concentrated area close by to the center. So all you need to have is that maximum wind, and that's where it gets its rating. So tropical depression is the lowest. We don't name those. We just give them numbers. If it intensifies to the next category, which is tropical storm, it needs to have winds of at least 39 miles an hour for that to happen, and that's when it gets its name. So Tammy, again, kind of just this disorganized grouping of storms. Sometimes when we see these systems first develop, at least when it comes to the classification, sometimes they will start off as a tropical depression, or in the case of Tammy, they'll just start it right off a tropical storm. Again, it has to do with the way the system is, and we talk about this. It's kind of interesting that some people might not know is that when these hurricanes are out in the middle of the ocean. All right, we have things like the hurricane hunters, which can take measurements when they go in, but a lot of times, especially when they're way out in the open waters, it's kind of hard to get an airplane over there. So they actually use something called the Dvorak system, which again uses satellite imagery, and there's some other types of satellites that can also kind of help to estimate the wind speeds and whatnot. So believe it or not, sometimes especially earlier on, it's an estimation. So you have to look for kind of, the structure of the storm. And so that's why sometimes you could see one starting off as a tropical storm, because again, tropical depression is just one step above a bunch of thunderstorms. So, but anyways, that's not the point. I'm kind of glazing over that a little bit. There's a little bit more that goes into it, but you get the overall idea. So, and the system that we do use, does time and time again show to be pretty effective, even though it's an estimation. A lot of times we see it, it ends up lining up pretty well. So unlike, some other things. So in tornadoes, we use damage to estimate the wind speed. There's no damage, we can't estimate the wind speed. So, that's how we classify things like that in weather. Obviously, it's very hard to measure tornadoes' wind speeds when they're very localized and not very long-lived, and, well, you get the idea. They also have such strong winds, it's kind of hard to find a piece of equipment that will withstand some of those winds sometimes. All right, let's move rapidly along here. Let's go back to the Saffir-Simpson scale. So again, once it gets to 74-mile-an-hour winds, it becomes a hurricane, and from there we divide them into 5 categories: 1, 2, 3, 4, and 5. 5 obviously being the strongest. It does not have an upper bound with its wind speed. So if you're looking at this chart, again, you see a lot of numbers there. The first number that you see on the top left, that is meters per second. We use that a lot in our equations. It's kind of the scientific standard, using meters per second when it comes to dealing with things in wind speeds. If you are a boat or a plane, for some unknown reason, we still use knots. I have my own theories about that, and it drives me nuts, though, that we still use knots. And believe it or not, folks, that's what the Dvorak system uses. It's actually knots. So they have to take the knots, and then they have to convert it over to miles per hour, and then obviously round it to the nearest 5. But anyways, yeah, so there's knots. The bottom left one, that's miles per hour. That's the one we're all familiar with, at least if you're in the US. If you're everywhere else in the world, kilometers per hour, bottom right there. So again, all the same wind speeds, just different ways, just different units, effectively. And again, like I say, in meteorology, I don't know why we still use knots. I think the theory was at one point they wanted a unified wind scale or whatnot, but I'm like, well, then let's just use meters per second. Okay, that way we don't have, but hey, no one asked me. All right, so that is a look at what is going on in the tropics. Hey, let's take a quick look over here before I ramble on anymore. Let's take a look at our good friend, the radar imagery. Let's see what's going on right now. And kind of the main thing right now in the upper Midwest is this area of low pressure. We took a look at it yesterday. It was further back off to the northwest. It's just kind of scooting its way through, bringing a few rain showers across parts of northern Minnesota and upper Wisconsin around where I am, as well as that little center right there of that low pressure. Now, here's something pretty cool that I do want to show you guys here in just a quick second is the surface chart and what that area of low pressure looks like on some of the surface charts here. Now, this doesn't have the fronts on it, and this might be a little bit of an information overload for some of you folks, or for some people, and again, that's quite all right. I don't expect you to understand everything when I show you this map. Just want to give you a heads up. It is a little bit out there. So let's go ahead and talk about, I'll move myself over here really quickly so that you all can see exactly everything that I'm trying to show you. Go ahead and move myself right over there. All right, let's take a look. This is a map right now. You're looking at Minnesota, Wisconsin, Iowa, Lake Superior over here, as well as Canada up here. This is a surface plot map. Now, to a degree, these are kind of dated a little bit. Obviously, with the amount of technology that we have nowadays, you can plot all these things differently, and you don't necessarily need these. But for those of you who aren't familiar with it, these are station plots. This kind of is a meteorologist's go-to when we're talking about conditions at the surface. So again, the red number is the temperature. In this case, it's in Fahrenheit. The green temperature that you see there, that's actually the dew point. These little wind barbs are the wind direction, and they're not like a wind vane. And these ones, they point to the direction that the wind is coming from. So this one right here is pointing to the northeast. That's where the winds are coming from. So these are northeasterly winds tracking down to the southwest. All right, a couple of other things you see here. These two little lines here, that's a symbol for fog. And then dots is for rain, a little drizzle over here, thick fog, some more little rain over here. So again, these are a little bit dated in somewhat of a way. Now, we still use them. As a matter of fact, when I do show you guys the surface charts and everything that we normally take a look at, oftentimes we will have those plotted. Now, the circle that you see here in the middle, that's cloud cover. So obviously, if it's completely filled in, it's overcast skies. If it's not, then it's clear skies. And sometimes you'll see this little black circle around it. That means the winds are calm. There's no wind barb there. So anyways, that's just a quick look at what you're looking at here. Now, the reason I wanted to show you this is because that low is tracking right over Minnesota. And you can actually see here, as you normally will with low pressures, but this one is just kind of photogenic, and it just happens to line up with these particular surface map zoom in area. But long story short, take a look at here. You can see how the winds are coming in from the northwest over here. We got that counterclockwise flow from that low pressure, and you can just see how those winds are just kind of going right around that area of low pressure. It's really cool there. Obviously, some gusty winds across parts of the upper plains, nothing unusual there. And obviously a little bit breezy across parts of Iowa. Now, we do these wind speeds, get ready for it, folks, in knots. I know, right? Drives me nuts. This little barb here is 5 knots. A long barb like that is 10 knots. And then obviously you just keep going until you get to 50, at which point you replace it with a triangle. We'll probably see that more when it comes to winter time. But right now, again, you can see about the good 20 knot winds, so about 24 mile an hour winds, sustained gusting to about 35 miles an hour over at this observation site in Aberdeen. So again, just kind of cool there. Just figured I'd show you guys that. And I know, again, I show this a lot when we take a look at the surface charts, and I don't normally explain it. So again, this is just kind of an example here. Now, like I said, if we zoom in just a little bit here, you can kind of see it a little bit up closely. Now, this right here obviously is the code of where that ASOS station is. In this case, this is Brainerd, Minnesota. Over here is Bemidji. There's Duluth, Ely, Hibbing, Graham Ray over here, Aberdeen. So you get the idea. 3-letter digit codes that we use. Same thing for airports. Again, we use these because this is oftentimes where these are located, are over at airports. There is the little number you see right here. That's visibility, in case you guys ever wondered about that. You see that. So 2-mile visibility here, drizzle. 5-mile visibility with fog is what that one says. 4-mile visibility, light rain. moderate rain, 2 mile visibility. So that's what those little numbers out in front are. And then you see these little numbers right here. Again, you guys are getting this all for free. How about that, huh? This is actually the pressure. And we use millibars when we talk about pressure. And believe it or not, it's kind of trippy to explain, but this is actually 1008.4 millibars is what this is saying. You don't see a point there, nor do you see the other two numbers. Well, again, for simplicity, we just list off the last three numbers. And we do the same thing, if the pressure was lower, obviously, we just list off the last three numbers. And that comes in, that does play a role when it comes to contouring these. So when I was younger, for fun, I used to, sit and contour these maps just for the fun of it. This was before iPads and everything, so But so again, you can get a lot of this information now. I mean, like I said, nowadays, we can have 5 different images for all of these different layers here. But some folks like myself still like to use these station plots here. I think they're pretty cool. So that is what that is. And like I said, the main reason I wanted to show you it is because, like I said, that center of low pressure is moving about right here. And you can just kind of see the way that wind is rotating right around that center of low pressure. And when I bring this up to you now, but keep in mind, folks, when we get to winter, this will be even more impressive to look at. And these are, like I said, really fun, especially if you ever want a fun contour challenge. These can be really fun to plot sometimes. So kind of a little bit of an old school thing there, but yeah, you get the overall idea. So that's what that is in the event that you ever see me showing these. I just wanted to show you it mainly for the wind. I mean, there are probably other ways I could have shown you the wind, but I wanted to show you it that way. The more you know. Alrighty, everyone. Well, I think I have probably confused you all enough for one evening, so we'll go ahead and wrap that up. So there, like I said, there's a quick little explanation about the surface plots, the MEDARs. And actually, you want a really confusing one? Let me see here if I can't. I'll show you something that's even more terrifying while I have your all's attention here. So you think that was confusing that I showed you? Go back over here to the, I'm going to flip you guys back over here. This is what it looks like if it's not on the surface plot, okay? There you go. Yeah, imagine getting that. Yeah, these are the hard MEDAR datas. And basically everything I just showed you on that little symbol will look like that in numeric terms. Pilots are familiar with these, and obviously, like I said, meteorologists, though, we don't really use these in forecast. I don't really use these much anymore. There was a time where I did, but like I said, you get the idea. Another way of just a 10-mile visibility statute, broken clouds at, what is it, 700 feet, 8,500 feet, it's completely overcast. You get the idea there. So time, wind direction, wind speed, again, in knots. And that right there is the airport. Now, here's a fun one for you guys. So let's go ahead. So I just showed you that scary looking thing. Let's go ahead and get it translated. That. That is what this down here, what I showed you, that is what this is saying. Okay. So these I use. Yeah, so that's kind of cool there. And again, there's the altimeter pressure, and then we mix that down to sea level pressure, which is what you see here in the millibars. And again, there's a lot more going on here with these. Again, cloud cover 700 feet above ground level. There's broken clouds, so mostly cloudy, 700 feet above the ground. Then once you go 8,500 feet above the ground, it's complete overcast. Winds from the east. There you go. Okay, everyone. I think I've scared you all enough for the night tonight. Hey, we'll be back here tomorrow evening. We'll take another look over at Norma. Like I said, Norma is probably going to continue to intensify, so maybe I'll post something about it this evening on Facebook. Maybe. Well, maybe. Or in the morning, I might. We'll see how strong she is in the morning. We'll take another look at her. But with that in mind, folks, hope you'll have a good rest of your evening. See you back here tomorrow evening. Take care, everyone, and keep enjoying the weather.